Welcome back to day 3 of e-learning. It should be Wednesday, and we went over the review yesterday. We are going to cover the homework we had from before break, which was page 430, 1 through 27. I will do my best to pay attention and explain what we're doing. So for number 1, it is called a spiral. That was actually at the beginning of the chapter. Number 2, BP is called the altitude to the hypotenuse, and that's in that bigger triangle there. Where you have it as altitude to the hypotenuse of the right triangle. Which segment is, between two segments, is BP the geometric mean? Since we have A and C here, it would be between AP and PC, because this over this equals this over this. And we know that by corollary 1 to theorem 49, which is number 4. Corollary 1 to theorem 49. The projection of EF onto the hypotenuse. Well, let's draw that triangle. We have E, F, P, and G. The projection of EF would be EP. Which two segments is EF the geometric mean? It would be EF is the geometric mean of EP and EG. And for number 7, how do we know? That is by corollary 2 to theorem 49. For number 8, you should have just had AD. Number 9 was DB. Number 10, they are the legs. 11, it is the projection. 12 is AC. 13 is CD, and 14 is CB. And that's using either corollary 1 or corollary 2 to theorem 49. For number 15, we're trying to solve for x. We're going to set this up as 8 over x equals x over 2, because we have the altitude. And you should have gotten that x is equal to 4. For number 16, we are not dealing with the altitude. We are dealing with this segment 4, this segment x, and this segment 9. So here we have the leg, so we're going to be looking at corollary 2, which means we'll have 4 over x equals x over 9, which means x would end up being 6. For number 17, we have these 3 parts. It might be helpful to rewrite it so that you have x, 5, 3, which means this side is 8. 5 over x equals x over the hypotenuse. You'll get x is equal to the square root of 40, which is 2 square root 10. So again, sometimes it's better to turn it so that it looks like what you're used to seeing. And remember to be looking at your theorem list. Corollary 2 again for number 18. I'm going to go ahead and draw it out first. So I have this is x, this is 9, this is 20. X over 9 equals 9 over 20. When you cross multiply this, you should get 20x equals 81. If you rounded it or made it into a decimal, it'd be 4.05. You could also leave it as a fraction. For number 19, it's a little bit more difficult, but not bad. We have 8 here, we have x here, we have 12. So I know the leg is the geometric mean between this part and the whole part. So I'm going to do 8 over 12 equals 12 over the whole hypotenuse x plus 8. Cross multiply to get 8x plus 64 equals 144. 8x equals 80. X equals 10. When we look at number 20, we're going to draw a diagram out. We have 9, 12. We're going to find DB first. So we've got A, D, B, and C. To find DB, we're going to do 9 over 12 equals 12 over, I'm going to call it X just to make it easier. And so we should get that X is equal to 16. To find AC using Pythagorean theorem, we would do, without using Pythagorean theorem, we would do 9 over, let's call that y. Y equals y over the whole side here, which in this case would be 25. And so our answer for this would end up being x equals 15, or y equals 15, excuse me. Remember, this is dB, this is AC. For 23, to find it using the Pythagorean theorem, we would end up doing the same thing, except we'd use 12 squared plus 9 squared. So AC squared equals 12 squared plus 9 squared. And we'd end up with the same answer. So for 23, you should also have 15. 24, we're going to find BC. That is this segment here. So I know this part is 16. So I'm going to do 16 over CB equals CB over 25. When I solve that, I should get that it's equal to 20. And then doing it through the Pythagorean, I'll get it equals 20 as well. For 26, you're just going to have 9 over 16, and 27 is 3 over 4. (46) is yes, it will work. 47 is also yes. They're similar by angle. 48, you should have had 5, because you can find the missing side using Pythagorean theorem. For 49, you're going to set it up as 5 over 4 equals 4 over x. So you get 3.2. 50 is 1.8, and 51 is 2.4. And you get 51 by doing 3.2 from 49 over z equals z over 1.8. And you get the answer for 51 again is 2.4. Nice thing is you can go back and reread any of these or listen to them again. And I'm going to pause it for now and then come back and do today's lesson.